Today I'm introducing you to Brisbane's new Turn Up and Go bus service, delivered via high capacity 100% electric buses across the 18 stations in the new Brisbane Metro network. In the video I'll talk through the details of these unique in Australia electric vehicles, the associated charging and depot infrastructure, then we'll go for a drive and we'll visit the Rochedale depot and check out some of this stuff closer up. So stay tuned.
This video is brought to you by ReGen EV Charging Install, Australia's residential and commercial EVSE installation specialists. Links to these sponsors are in the show notes.
Well, thanks for joining me and welcome to a video I've been planning for some time now, as I'm super excited about this addition to Brisbane's public transport. Now, we know the answer to improving community health, traffic congestion and transporting people around more sustainably is to have better availability and patronage of mass public transport. And I think this new Brisbane Metro will be a game changer. Now, this new service covers high density population areas which aren't serviced well by the train network, and it'll connect 8 Mile Plains on Brisbane's south side, the University of Queensland at St Lucia in the western suburbs, and the Royal Brisbane and Women's Hospital at Hurston, which is just north of the Brisbane River. Now, I was hoping to get an interview for this video, but I haven't had a response from the project team so far. So that's something we'll do at some point in the future if we can get hold of someone. But let's get into the detail I've been able to put together. So the project's estimated to cost about $1.4 billion, and that'll be jointly funded by the Brisbane City Council and also the federal government. Now, while that might sound like a lot of money up front, as we know, governments often waste money with projects that don't deliver what they expect. I think this one will be good value for money, so looking forward to seeing if they do come in on that number. As mentioned, it'll have 18 stations with 11 interchange locations. Now, there's been 3 companies involved in this, or 3 main companies. That's Hitachi Energy, Volgren and also Hess. Now, they've been involved in delivering the vehicles and the electrical infrastructure for the project, and we'll delve into shortly more about those, and we'll have a look at the 3 companies involved. So look, firstly up, Hess Australia. So it's trading as Hess E-Mobility Proprietary Limited. So this is a company that's obviously been set up in Australia just to deliver this project, I would say. And it's an arm of Hess AG, and working with long-term local partner Volgren Australia to provide the state-of-the-art e-bus systems in Australia and New Zealand. Now, from what I can work out, the Hess e-bus technology, which is the OEM modular aluminium bodies, are being manufactured here in Australia by Volgren. And that's where it'd be good to have an interview and we could find out a bit more about that. But from what I can work out, that looks like how it's working. So a little bit about the parent, Hess AG. So they were founded in Switzerland in 1882 and they made their first electric buses in 1940, so they've been doing it for a while. They manufacture approximately 2,400 buses per year, and over 860,000 people per day travel on Hess electric buses in Switzerland, so I thought that was an interesting little point to put in. Now, they've got lots of different models, including trolley buses, airport shuttles and utility vehicles for the Swiss Army. So that's the Hess parent in Switzerland, but the guys in Australia are called Hess Australia. Second company involved, Hitachi Energy. Now, their parent company is obviously a Japanese company called Hitachi Limited. Now, they're using the technology called grid emotion flash, and we'll look at more of this later. But basically, that's the ultra-rapid charging pantographs and the onboard traction equipment within the buses. Now, they say in general that their systems deliver energy cost savings of over 30% compared to diesel buses. So yeah, interesting little stat there as well. Now, they also provide a end-to-end service called Grid Emotion Fleet, and they say that's a scalable, modular and fully customizable solution for large-scale EV charging of smart public and commercial transport. Now, the third company is Volgren. Now, their parent company is now owned by a Brazilian company called Marco Polo, and they're one of the world's largest bus body manufacturers. Volgren was born in 1977 by merging the names of Volvo and Granada Corp. Now, Granada Corp started in 1945 in Dandenong in Victoria with milk runs, and they built the electric vehicle floats, which is what they call those little electric vehicles that used to deliver the milk to households. Now, Granada agreed to distribute Volvo bus chassis, and using Hess bus bodies made their first bus in 1979. So you can see these companies have had long associations, and they're obviously building on those. Volgren is now Australia's largest bus body builder. Headquarters are in Victoria with operations in Queensland, New South Wales, Victoria and WA. And they're now building all types of electric buses. So that was a quick look at the three key companies involved and a little bit about the parent companies behind them. So now let's have a look more specifically at the vehicles themselves. So they're based on a Hess Light Tram 25 TOSA, T-O-S-A, I don't know whether that's how you pronounce it, model E-bus. Now look, the 25 stands for 25 metres, so they are approximately 24.7 metres long, so quite a long vehicle. They're 100% electric, so obviously zero tailpipe emissions, low noise and vibration levels, and that's really important for the residential area that's gone up around the depot, and we'll have a look at that when we go down shortly. Now look, there's 60 vehicles in total making up the Brisbane Metro network. The vehicles can carry 150 passengers in general normal use, and they can carry 170 in event mode. So I'm assuming that's when the big footy matches are on, the Taylor Swift concerts, so you can fit a few more people in standing up. They're a three-part articulated vehicle, as you'll see by the videos behind me, and they do look like a tram, except they have no overheads or tracks. So obviously they're rubber tyre based, and because they've got the batteries on board, they don't need those overhead cables. Now, 2 of the 4 axles have electric drive, and they've got front and rear steering. Now, of course, because they're electric, they've got ReGen braking, which is a fantastic advantage of electric vehicles. So when you're slowing down, instead of just using friction brakes and wasting all that energy is going back into your battery to recharge it. So that's great. They also have driver assistance technologies and onboard telematics. And I really love the video from Brisbane City Council there showing the emergency braking trials. The vehicle stays nice and stable, and it sort of scrunches up. It looks a bit like a slug. So really good to see that they've done all that testing, and these vehicles look like they handle very well. Now it has 3 double doors, and it'll have all door boarding. So this is something that has been in Europe forever, that all the doors open on a bus and people can get in and out at all doors. I don't know why, but in Australia we've always usually had front door boarding. So these will allow a lot quicker exits and entries to public transport, which is great when you've got large volumes of people to move. They've got USB charging and Wi-Fi on board, and internal passenger screens to tell you the next stops and timings and all that sort of stuff. They're the most accessible vehicles, and they're aiming to exceed compliance with disability standards, and that's after extensive consultation with disability groups. They've got 10 priority seats, and they've got 3 large mobility aid bays, so you can put your walking aids and all that sort of thing and stow them. And the entire length of the bus has a low floor. Even though some of the seats are elevated, it means somebody on a wheelchair can get the full length of the bus. It's got next stop audio and hearing loops throughout. So obviously, not having a disability myself, these are things that you don't think about, but just having hearing loops, etc., is going to be really helpful for people with hearing disabilities. So let's move on to the associated infrastructure now. So they will use the existing busways with some additional upgrades. I'll put a map up there which shows the routes. So there's a Metro Route 1 and a Metro Route 2 that links those locations we mentioned early in the video. And it will also link up with the new Cross River rail services and stations. There's a new dedicated bus tunnel which has been constructed under Adelaide Street in the city. So there is some existing bus tunnels, but this is a newer one they needed to build. Now the new Metro depot at Rochedale. So this is where all the new electric buses will be stored and serviced and that sort of stuff. And they're aiming for a 5-star Enviro rating at that facility. and it'll have 60 what they're calling slow chargers, and we'll talk a bit more about that shortly, but they're not exactly slow chargers. And they've got 5 flash chargers, so we'll talk more about that as well. Recycled and rainwater used in the wash bays, so they'll be washing the buses down with either rainwater or recycled water, which is great to see. And it's got a massive 1 megawatt of on-site power generation via PV panels on the roof of the buildings down there. But as we mentioned, the big advantage for me and the local residents around that depot and also the wider community is there's going to be no diesel exhaust fumes and noise, because as I said, there's a new housing estate down there. So we mentioned chargers briefly. Let's talk a bit more about those. So the flash chargers at this facility are going to be 600 kilowatts. So they're the ones with the pantograph, and that'll be at selected stations and layovers. Now in normal electric car or EV world, we would call these ultra rapid chargers. Now these are some of the biggest or the biggest chargers you can get. So normally that would be any charger over 150 kilowatts is called ultra rapid charging, and these are 600 kilowatts, so they're absolutely massive. Now there'll be 15 in total, as we mentioned. These buses 85 times quicker charging on the flash charging than my home charger. So that's absolutely massive. Now those flash chargers will be the UQ Lakes station, so that's the University of Queensland. They'll also be at a Petrie Terrace interchange, Hurston layover and the Rochedale depot. They use an overhead pantograph, as we mentioned, and it has a mechanical arm coming up from the vehicle to lock into that charging pad. And they'll recharge in about 5 to 6 minutes. Now that's the headline that is on the website, but I'd like to know at what state of charge the battery starts at. So 600 kilowatts, it's a very fast charger, but 5 to 6 minutes. Let's see the size of the batteries firstly and at what state of charge to quote that 5 or 6 minutes. But obviously this is for when the bus just stops in for a couple of minutes, they can whack some charge in, maybe the driver goes to the toilet, comes back and off they go again. So these will be used when the buses are cycling in service. They won't be when they're outside the peak, so these will be charging while they're working sort of in that peak hour, morning and afternoon. So the slow charging, now that's what they call slow, but in, again, normal EV world, we call this rapid charging. So rapid charging is anything between 25 and 150 kilowatts. Now these ones are at 50 kilowatts. So they're at the smaller end, but there's 60 of these. And again, we'll have a look at these down at Rochedale shortly. They have a CCS2 plug on them, and for all intents and purposes, they look exactly like a normal DC rapid charger that you would go to with your normal EV. Now there's 60 of those, as I mentioned, at the Rochedale depot, and they're for off-peak charging. Now when the buses are sitting around, whether it's 4 to 6 hours between those peaks sort of thing, or at the end of the day, there's no need to charge them really fast. So these chargers will be absolutely perfect. Now the exciting thing for me is that they have load management. And what that means is they can balance the demand on the grid with the demand that the depot is pulling. So this is all controlled by smart. So it's not like a dumb charger when you plug it in and it goes flat out. They'll be able to control these 60 chargers as and when the demand is on the grid. So let's talk a little bit more about that, and in particular the remote power units. So these look like demountable buildings. They're quite big. They've obviously got some good air conditioning in them to keep them cool. You can see all the fans and vents on them, but this will have all the AC, DC, DC to DC rectification, inverting and all that sort of stuff. And then the cables just run out to the actual dispensers. So that's the rapid charger dispensers that we talked about, and also the ultra rapid overheads. So all the smarts and electrical controls are in those buildings. Now I've mentioned a couple of times that there's lots of gaps in the information, and I'd like to do another video. So some of the things I'd like to know on the vehicles in particular, were they fully made in Australia by Volgren, or were they imported in part from Switzerland and just put together here in Australia? And are they being 100% serviced by Volgren at that local Rochedale depot? I'd also like to know the full specifications of the vehicle. So there's lots of stuff we don't know, like the drive system power, the battery chemistry being used, the battery capacity. It'd be great to know the service intervals of the vehicle. So how many kilometres or time between services, what the requirements of those services are, and the projected vehicle lifetime. So how long do they think these buses are going to last? Now look, I've travelled on trolley buses in Europe that are around 40 or 50 years old, and they're looking a little bit old, but they still do the job and reliable. So it'll be interesting to see how long they expect these ones to last. Also the fuel costs and the comparative emissions savings. So we talk a lot about saving money on fuel, but I'd also like to know the emissions. So have they calculated the emissions that these electric buses will save over their lifetime compared to diesel buses? And even if they're Euro 6 or Euro 7 buses, which is the modern European standard of diesel emissions, there's still some emissions. And as we mentioned, there's lots of noise and vibration as well. So as a regular user of these bus services, I really appreciate when I get on one of the new electric buses and there's no vibration, they're quiet, it's a lot more comfortable ride for the passengers as well. It'd be great to know the initial vehicle costs and the whole of life cycle costs, so including all the energy they'll use and the service costs, and feedback from drivers. So as a passenger, I just mentioned it's great to be in an electric bus, but I'm assuming, and I have heard from various drivers, that they are a lot nicer to drive. They're easier, less vibration obviously, and you're just not as tired at the end of your shift. Now there's also some questions I'd like to know on the infrastructure. So the full specification of those power units we talked about, and including the round trip efficiency. So when you're doing lots of different things and switching electricity and that, you have losses. So it'll be interesting to know what the efficiency is, what the ongoing maintenance is of all those electronic components, etc. Is there much involved or not? Is that all done locally, and who does it? The expected amount of daily energy consumed on the site and on the bus network, and also provided by the on-site solar compared to the grid consumption. So it'll be nice to have a comparison there. Is there any additional battery storage on site besides the vehicles? So I'm really interested to know if they're looking at any vehicle to grid or vehicle to base type exchanges between the batteries, because I think this would be the perfect site to do that. You've got 1 megawatt of solar, you've got a lot of vehicles with obviously high capacity batteries in them, but they could still also put some on-site battery storage to help stabilise and support the grid. So interesting to know whether they do that. What happens in power outages? Now look, somebody will ask this in the comments, so I would like to get this out there now. Are they going to have diesel generators? How much capacity can they provide if the grid does go down? Can they share it between vehicles? All that sort of stuff, so that would be good to know. And how, well, I just mentioned that, how long the facility can be offline before grid services, sorry, we'll start that one again. How long can the grid be offline until that starts to impact bus services? So obviously I'd imagine they can be offline for a couple of hours, but if you're in the middle of the morning or afternoon peak and the grid goes down, the good thing is if it's likely to go down, it will only usually go down in one area. So you may not be able to charge the buses in that area, but hoping you could charge them in one of the other locations. So probably not a big deal, but again, somebody will probably ask it in the questions. Well, that's it for my research. Now let's hit the road and we'll go down and we'll check out the Rochedale depot in the flesh, and we'll see some of these things we've been talking about. Let's hit the road. Well, here we are just down the road from my place at the new Brisbane Metro Rochedale depot. Now, apologies for the car noise. It's quite a busy little street here, so there'll be lots of cars going past. As I mentioned, there's lots of new housing estates going in around here, so this is great that this depot has electric buses and not diesel for the local residents. And I'll grab the camera in a minute and we'll pan around a little bit and we'll have a look at some of these things a bit more closely. As I mentioned, unfortunately we're on the outside of the fence because we haven't been able to get an interview and get inside, looking to do that in the future. So just zooming around a little bit, so that's the street. These are newly constructed residential units. There's quite a few units in there, so they're right next door to this new facility. And you can see some of the PV there, so that 1 megawatt of PV. Sorry for the quick zoom. Now this looks like the admin buildings, so the administration sort of, maybe driver quarters, that sort of stuff. So yep, fully covered in solar panels. And it's really tricky to get a good shot through this fence. So I'm holding this up above my head. But look, they're the buses. So they're the 3-part articulated buses. And if you look closely there, we'll zoom up some more. There's the 3 doors we talked about. And there's the chargers. So they're those 50 kilowatt DC chargers. Now I've put some Brisbane City Council footage up in the video, so that'll show these a lot better. But yeah, they're the chargers. So they're what they're calling the slow chargers, the 50 kilowatt ones. And over there, we've got one of those buildings I talked about. So that's housing all the electronics, rectification, inverters, all that sort of stuff. And you can see it's marked with Hitachi there, and it's got a lot of air conditioning units to keep them cool, because here in Queensland it does get very, very hot in summer, and that's when you don't want failures from electrical stuff. So we'll go further down in the facility, but that's the end. It looks like it's up at the admin side. They're the slow chargers, so that's where the buses will sit overnight. And the shed behind there, that looks like the maintenance or workshop facilities. So again, we'll walk down there shortly and see if we can get a better shot of those. But that looks like where the buses will be serviced. So here we are, we've came a little bit further down the facility, and this looks like what will be the workshops. Now I should have mentioned, these services aren't actually operating as yet. We're expecting them to kick off in about the next 6 weeks or so. So this facility is very near finished, as you can see. More solar panels on the top that making up that 1 megawatt of generation capacity. Interestingly, those doors are all insulated, so it's quite a efficient building. Like we said, they're aiming for 5 stars. So yeah, I could see when they were building it, those doors that go up there to let the buses in and out, they're heavily sort of insulated. Don't exactly know what this section is here. It looks like it's going to be some landscaping, maybe car parks for staff, don't know. Over in the background, that's the M1 motorway that goes to the Gold Coast if you're heading south. And the existing busway is just there as well. So between where you can see those vehicles and the dirt, there's a busway there. So that's where the buses will actually come off the busway and into the depot. Okay, well, we're back again. We just had a memory card fill up, so we've swapped that out. And this is probably as close as we're going to get to the facility where the flash charging is. So as we mentioned, the north end of the facility is the driver's sort of admin type area. The centre's the workshop, and down here in the southern end we have the ultra rapid chargers, or the flash chargers as they're calling them. So if we try and zoom up there, you should be able to just see the pantographs hanging from the roof there. A little bit hard to make out, but as you've seen in some of the other footage I included, that's them there. So the arm comes up from the bus, connects into that, and they deliver 600 kilowatts, which is a huge amount of energy to the buses in 5 or 6 minutes, as they said. And again, there's some more power units there, so more demountable building type things, lots and lots of air conditioning units on them to keep them cool in the Queensland summer. There's a huge amount down there. This looks like double the amount that's up at the other end with the normal 50 kilowatt charger. So it just goes to show the amount of energy that those ultra rapids suck up. Well, that's it for another video on site down here at the Brisbane Metro Rochedale bus depot. Look, big shout out to all my supporters. If you have been, thanks very much for watching the video. Do all those usual things, give it the thumbs up and share it with your mates. Just checking on the latest stats. So in the last month, we've had 82 new subscribers. So thanks guys for signing up to the channel. We've had 9,362 total views and we've had 57,000 hours of videos watched on the Electric Car Australia YouTube channel. So really appreciate that. Now on the way down here, I just dropped in to have a look at a site where we've done a recent video on fire ants. If you haven't seen that one, check that one out. I'll put a link up above. And they're now building houses on some of the areas that we had numerous nests, and I just had a quick look in there. It looks like they have treated the nests and they are now dormant, so there's no ants in there, which is great news because now they're building houses on it. So yeah, that's a bit of a one-off one that we done on fire ants, one of our videos that we call the Fireside Chat, which is not strictly electric vehicle type videos. So check out all the other videos in the channel if you haven't and see what's there. There might be some stuff of interest to you. Well, again, thanks very much for watching. Thanks to our sponsor, ReGen EV Charging Install, and also thanks to one of my lovely viewers that gave us a $10 shout out in the last month. Really appreciate it. So until the next video, take care, stay safe, look after your friends and family, and we'll talk soon. Cheers.